So the next part of 28.3 is going to talk about our beginning process of sketching some polar graphs on the grid. A couple things before we get started to make sure. So we've talked about converting, but one thing we're going to do is we're going to look at the function 6 cosine of theta. So 6 cosine of theta. Now, in order for this to be plugged into your calculator, you need to make sure you have two things happening. Okay, first off, you want to go under the mode menu and make sure you have degrees selected. You're also going to have the polar function selected as opposed to function is what's normally selected. And what this allows us to do is when you go under that y equals menu, you now have r equals 6 cosine theta as opposed to using x and y's. Now, if we want to look at a table of values, notice they want us to do 0, 30, 60, 90. One thing you do is if you hit second window, pulls your table setup menu. And what we're going to do is we're going to start our table at 0, go up by 30s. And what we're going to notice is those first points, 6, 5.2, 3, and 0. If we start plotting those, 1, 2, 3, 4, 5, 6, 5, 3, and 0, I have a semi-circular approach to this picture. And if we consult then further down, the rest of this graph, right, and we plug in, we have 120, 150, 180. What it ends up doing for us is when we plot those points, we confirm that this has a circular nature. So again, it's like going back to plugging in x's and seeing what y values you have. We're doing that same process with theta and r. Right? We're just allowing the calculator to kind of do the work for us. Otherwise, we can just type in our thetas ourselves to get these values. Now, where are we going with this? This is turning into the equation of a circle, which we're familiar with so far. And if we look at example B, why algebraically is this happening? So here was our original equation, r equals 6 cosine theta. And we talked about earlier in the lesson, right, part 1, that r equals the square root of x squared plus y squared. And then we can plug that in for the r value. So you see that happening right here. And then officially, if you look over here, cosine is x over r. So if we substitute in again for r, that square root of x squared plus y squared, we now can substitute in for cosine, that value there. So that's where these guys over to the right, these formulas are coming into play. Over here is making that substitution in. Well, if we multiply both sides by that square root that we have on both sides, this left-hand side just kind of cancels out. The square root times the square root is just the stuff underneath the radical. Over here, we're left with 6 times x. And based on part 5a of this chapter, we know all about completing the square to get that equation of a circle. Which again makes sense with what we had on the previous page because we had a circle that looked like it was shifted over to have a center at 3, 0, just like this shows, and then our radius value of 3. So that process is going to allow us to look at now the polar form of this equation versus the rectangular form of this equation. So substituting in and simplifying algebraically is going to allow us to do that.